Greetings, welcome. So in this lecture I want to go and focus a little bit on, this is a different kind of exponential function because the base is not e, but it is one that you're going to want to be able to understand. This one also definitely shows up. And so I'm just going to go through how you would integrate it, both kind of with the rule and two examples. So let's go ahead and do this. So suppose that we have maybe I'll make this be red. So I have this b that's greater than 0 and not equal to 1. So I want to say b is not equal to 1. Okay, so if we're in this circumstance, then we're going to have that the integral of b to the x dx, so I'm going to put a b in there, is going to equal, so I've got 1 over the natural log of b, so this is that b, right, and notice that this is a constant. That's kind of couldn't end up being important. And then we have b to the x plus c. Okay, so I'm just going to kind of emphasize that. So we're multiplying the function by a particular constant. Okay, so this is a particular constant. And an important one, because when you integrate, you kind of pick it up. Okay, so let's get started with an example. So example 1. Okay, if I want to take the integral of x, 3 to the x squared dx, okay, so this almost looks like something that would happen there, where 3 would be my b. But notice I have an inside function here. My x squared has replaced my x, and I have its derivative next door. So this is a substitution problem. So I want to take that, for my substitution, I'm going to want to take u equals x squared. So then for du, I have to take the derivative of this. So I have 2x dx. And then I have du over 2x is going to equal dx. Okay, and so now I can go ahead and kind of substitute everything in. So I'm going to substitute in. So what I'm doing here, just kind of remark on that, is I'm going to substitute in u equals x squared. Okay, and what ends up happening is that I get the integral x, and then I have my 3 stays there, but then I have my u is going to replace there. Maybe I can put a, you can just put my, because I put in that there. And now I have to replace my dx, and so I replace it with du over 2x. So that's kind of the other replacement that went on there. Okay, and then we're happy campers because these x's cancel, and I just get a 1/2 in front. So then I get, this is going to equal, let's just kind of put a line there for ourselves. So this is going to equal 1/2. These x's are going to cancel, and the 2 has been pulled out. So what I'm left with is the integral of 3u du. Okay, now this looks just like this one, except where 3 is my b and u is my x. Okay, so I can go ahead and write this is going to equal, and then I have 1/2, right? So, and then maybe I'll note what I'm doing here is right, so I have that b equals 3, u equals x. Okay, so I'm getting 1/2, and then I have 1 over the natural log of 3, right, because that's my b, and then I have 3 to the u plus c. Okay, now because this doesn't have bounds, and my original integral was in terms of x, I need to put in for x, and so, or for u to get this in terms of x. And so I go ahead and do that, and I'm going to get this is going to equal 1 over, and I'm just going to combine these, right? When we multiply fractions, we multiply the numerators and we multiply the denominators. It doesn't work with addition of fractions, it works with multiplication of fractions. So I get 1 over 2, the natural log of 3. And then I have 3, and now I need to plug in that u from over there, so that's just going to be x squared plus c, and I'm done. Okay, so before we jump into the next one, we can talk about this one for a second. So it has this format, except we have to do a u substitution to put it into that format. You know, kind of the hint is that we have some kind of constant to some kind of power that has x involved in it. So it might be a good indication that you might want to use substitution. And we have the derivative of what's up there next door. We always want that when we have substitution. So we go ahead and do our substitution. We have u equals x squared. We have du equals, so we have the derivative of x squared, so that's 2x dx. And then I just solve for dx so that I can replace all that in over here. And we're happy then because, right, we replace the dx with du over 2x. We replace the x squared with u. And then these x's are going to cancel. I can pull out, I have a 2 on the bottom, so I can pull that out as a 1/2. And I get the integral of 3 to the u du. And then I am exactly in this format, except that my b is 3 and my u is x. So using that, I actually am able to get here this integral. But then we remember this was a substitution problem, and I'm supposed to be in terms of x, and I don't have bounds, right? When we have bounds, so when we're a definite integral, we do not substitute back in, but we're not a definite integral. We do not have bounds. We're an indefinite integral. And so we do actually need to substitute back in order to make it in terms of x. So we do that, and we get this integral. So let's do one more. Okay, so this is going to be example 2. Okay. So for this one, I'm going to take the integral from 1 to 4. So this time we do have bounds, so that's something to keep in mind. And we have 6 to the negative square root of x over the square root of x dx. I like this one because it involves a lot of things that you're going to have to try to sort through, so it's good to, you know, I thought it was good to like combine a little bit of the things that we've been doing, so hopefully this will help illuminate some of the things that might be a little more confusing to you. But you can see that there is an inside function here, and don't get kind of thrown off by the fact that this is in the bottom, because if you think about it, if you take the derivative of this, you actually end up with a negative exponent, which means you're going to be in the bottom. Okay? So this is where we're going to have, so we're going to do the substitution, so this u is going to equal, and this is, so right, so this is negative the square root of x, which we have to remember is negative x to the 1/2. We like to do that if we're going to be taking derivatives or integrals so that we can deal with the powers appropriately. Okay, so then we have u equals minus x to the 1/2, and this is where we start to feel a little bit more comfortable because we get our du is actually equal to 1/2 minus, right, so then we have our minus, so you put that out in front, and then we have to take 1 away from this power, but when you take 1/2 minus 1, you actually get a minus 1/2. So that's good news for us because that's going to mean that it's going to be in the bottom as we would like. Okay, but then when we multiply this to the other side, right, this is actually currently in the bottom, so it comes up to the top, and I actually am going to get minus 2x to the 1/2 du equals dx. Again, this was a minus power, which meant it was really on the bottom, so that when we multiplied it to the other side, it came to the top. This is just kind of like what happened with minus 1/2 became minus 2, so that was actually even a nice way to kind of illuminate what happens there. Okay, and it might be helpful to notice here that this is like minus 2 times the square root of x du equals dx. Okay, so now we can kind of go ahead with this. And so, and this is one of these ones. This is a definite integral. It has bounds. We definitely need to put our bounds into this. So we have u1 and u4. Okay. And then this becomes u. So I have 6 to the u. And then for the moment, I leave that there. And then I replace dx over here. So I replace it with, and we get minus 2x. But we decided to do it that way so that it was easier to see what we're doing that. So we do the square root instead of the power portion, and then we put a du here. And now we're kind of happy because we have a square root of x on the top and the bottom. So those are going to cancel out nicely because we don't want any x's floating around anymore. So we go ahead and do this. We get, this is going to equal, so I get I'm going to pull out a minus 2. And we can evaluate these, right, by putting them into here. So I get the integral of, and then I have a u equals the square root of minus, right, so minus the square root of 4. That's where the 4 is going to go into here. So we have u equals minus the square root of 4, which that 4 becomes that one, which is going to equal minus 2. And now we're going to put this 1 into our u function. So we're going to get u equals minus the square root of 1, which is going to equal minus 1. Okay, and then this is just, now these things cancel. The minus 2 is pulled to the front, so I'm done with just writing 6 to the u du. Okay, and then at this stage, I can just go ahead and use, right, this up here. So let me just, I want to write this without so much clutter in it. So this is the integral from u equals minus 1, u equals minus 2, 6 to the u du. Okay, so the clutter's down. And now I can look at this and I can be like, okay, so this is going to equal with, and then we're putting in here the difference b. So we have our 6 for our b. Okay, so we're going to do 6 equals b and u equals x, and then we can just use this formula straight ahead like that. And so this is going to equal minus 2 times, and then we do it with this here. So I get 1 over the natural log of, and our b is 6, so we put that in there. And then we have to do our 6 to the u. Don't get that confused there. Okay, and we don't need the plus c because we're a definite integral, but I do need to evaluate that at my bounds. U equals minus 1 and u equals minus 2. Okay, and then we can just kind of continue on from here, right, where this is going to equal. I'm just going to kind of step down a little bit here for this. Okay, so this is going to equal. So we have to do, we can leave out the minus 2, and then I'm going to have to put in the two things where I kind of leave my 2 as parentheses for a moment. So I have 1 over the natural log of 6, 6 to the parentheses. And then I'm going to subtract off where I do that entire thing. Our u gets replaced with the parentheses if we do this correctly. Now we can put in our minus 2 and our minus 1, and they're u bound, so we're happy they can go in for u. Okay, and so this is going to give me, what I'm going to end up getting here is, so let's think about this for a moment. So what do we have going on here? So this is kind of like 1 over 6 squared, right, because that's a minus there, which is going to equal 1 over 36. And this here is just going to be 1 over 6. Okay, so we get, and now because I have this in each of these terms, I can go ahead and kind of pull it out. So I've got minus 2 over the natural log of x times, and then I have my 1 over 36 minus my 1 over 6. We can put these over a common denominator, so I have a 6 over 36. Okay, and so what I end up getting is minus 2 over the natural log of 6 times, so, right, so this here, to help us out for a moment, if I put this, to get this over a common denominator, I have to multiply the top and the bottom by 6, so I get 6 over 36 here. And so I end up getting that I'm going to multiply this by, so 1 minus 6 is going to be minus 5 over 36. Okay? And so this is just going to give us 5 over 18 times the natural log of 6. And we're done. Okay? So this one was a bit more complicated, but this is just another substitution problem. This one had bounds on it. I was sneakily giving you a little more practice with substitution. So in this substitution, this is also, I wanted to kind of give you a little more practice with this possibility of having, sometimes when you have a square root of x in the bottom, it's actually because of a substitution that when you took the derivative of the square root of x, you actually get, you know, a negative power, which brings you down to the bottom. Okay, so it might not immediately look like a substitution problem, but it is one. And so we just kind of did substitution like normal. So this was a derivative of that. Everything kind of canceled out. Now it's all in terms of u, and so we don't ever go back because this one has bounds. But I do replace, right? So I use this formula where my b is 6, my x is u. Okay, then we can just put it into the formula, and after that the only possibly tricky things are just kind of reducing this down for ourselves, because sometimes exponents and fractions are tricky. So this is 1 over x squared, right? Sorry, 6 squared, because we have a minus 2 in the power, and a minus 1, right, just meant that we just kind of flipped the thing. So now we've got to, and we pulled out, we have a 1 over the natural log of 6 in each of these, so we pull this out. And so now we're taking 1, right? So with fractions, I had to put these over a common denominator, but once I did that, I could just subtract the numerators. I kept the denominator the same, but I subtracted the numerators to get a minus 5 there. Okay? And so that's what we get in the end. So I hope that was helpful, and I will see you in the next lecture.